Welcome to Physics with Mr. Brazil. Today we're going to derive the range equation. That's the equation right here in the middle. It's delta x equals v initial sine 2 theta over g. You tend to see this online just like this or in a textbook. That's how some teachers write it. That equation only applies to like a football field, a flat ground, where it starts at y initial, a parabola, and ends at y final is 0. So in other words, y initial starts at 0 and y final is equal to 0. We do have a change in x, okay, delta x, a final and an initial, and that will give us our range where it will land on the ground. Okay, so this is for no cliffs or shooting up to a cliff. There is a theta and there is an initial velocity, but that initial velocity is made up of two components. Vx initial, which is equal to Vi cosine theta, and Vy initial equal to V initial sine theta. Okay, so there are component vectors going to the right in the x direction and in the y direction going upward. All right? And you can apply Pythagorean theorem if you knew both. So let's use these. First of all, we're going to use our kinematic equation. I'm going to go in the y direction first. Y final equals y initial plus Vy initial t plus 1/2 gt. And that's because an object that's in flight or having projectile motion has an acceleration of g and t is squared. So this is, I call it the Swiss Army knife equation. You can derive other kinematic equations from this. Y final is equal to 0. Y initial is equal to 0. That's a good start. Let's look at the x direction. We have x final. That's equal to x initial plus Vx initial times t plus 1/2 ax, acceleration in the x direction, but there is no acceleration in the x direction. The Vx initial is constant. There is no acceleration. The speed in the x direction is constant, so this is 0. Bring our, and I noticed that I used not. That should be an I. I'm old school. Let me put that in the proper color. So Vxi, that's initial. The old school is x naught. Sorry. All right. But I'm going to bring this x initial over, and that's going to be delta x is going to be equal to V initial. I'm going to change that Vx to cosine theta times t. Ooh, interesting. Both equations have t. All the vectors share the same time. Okay, these three vectors, well, I have the two vectors here, but it's three vectors, share the same time. Okay, well, that allows us to solve the x direction. Well, we could put t equals del x over v initial cosine theta. That's going to be applicable. Now we can substitute this t in for these t's. So let's do that. We're going to have a 0. It's going to be equal to, and I'm going to change the vy to vi initial sine theta times t plus 1/2 gt squared. Okay, let's go one more time. So v initial sine theta times del x over v initial cosine theta. This looks kind of promising. Plus 1/2 g times del x over v initial cosine theta, and this is squared. All right, let's put this together. 0 now equals, okay, VI's cancel. So we're going to have delta x sine theta over cosine. Yeah, I get tempted to put tangent. Don't. You'll see why in a moment. Plus, let's put this together. So g times del x squared, 2 times v initial squared, cosine theta squared. I'm going to keep that in parentheses. And immediately we notice something. There's a delta x in the numerator, and in the denominator there's a cosine. What we could do is multiply both sides by cosine theta over del x. So I'm going to put cosine theta over delta x. I probably should have put more room here, but that's okay, because that's only going to give us 0 on the left. But x is going to cancel out, cosine is going to cancel out, so we're going to have sine theta plus, and we're going to get rid of one of the x delta x's, so there's a 1 here, and we're going to get rid of one of the cosines, and there's a 1 there, so we're going to have g del x over 2 v initial squared cosine theta. Okay, well, we're getting somewhere. Let's bring the sign to the left. So negative sine theta equals g del x over 2v initial squared cosine theta. And let's bring it up here to the right. So delta x is going to be equal to negative v initial squared 2 cosine theta sine theta over g. Whoa, doesn't look like the range equation. Well, wait a minute. Here's what we need to do. There's trig identity. So 2 cosine theta sine theta, well, that's equal to sine 2 theta. Well, that changes everything. So let's give that a shot. So del x is going to be equal to, and I'm going to bring the negative down to the bottom. So we're going to have v initial squared sine 2 theta over g. Negative g. Wait a minute, that doesn't look like the range equation. How the heck did that happen? Hang on. What's happening is online and textbooks, they like to do this right here in the middle. It's negative times a negative 9.8 or 8.1 or 10, but meters per second squared. That's positive. And so what they write is g as a positive. So you need to remember when you're using a textbook or online website, they may have a positive g. Just know that it's a positive 9.8 meters per second, okay? But the actual equation as derived is what we've got right here in the bottom in the red box. All right? Review the video, pause it in certain sections, practice. This is a good skill set. Physics is all about substituting little algebra equations into each other to solve and reduce something from 2 unknowns to 1 unknown. Okay? Keep practicing and enjoy physics. Bye.